Hi, hello everyone. Welcome back to study with me. It's me Vidya here. So we have already dealt with the reflection. What is reflection? What are the types of reflection? And what are the laws of reflection? Right. So here today we are going to deal with a plane mirror. Okay. So what do you mean by a plane mirror? Plane mirror. So you see we have the mirror in our dressing table. That is a plane mirror. Okay. So let us have a look into how it is working. Fine. So let me consider this as my plane mirror. Okay. So if we are considering the surface of a mirror, this will be the reflecting surface and this one is the polished surface of a mirror. Okay. So this is the polished surface of the mirror and this is the reflecting surface of the mirror. So let me consider I have an object AB. Okay. So I have an object AB. I have placed this object here. Okay, so let us see how the reflection is happening in a plane mirror. Okay, see, this is how for example, this is how the light rays are falling on the surface of the mirror. Let us consider these two are the light rays which are falling on the surface of the mirror. That means these two are the incident rays. So how the reflection happens is when it reaches this surface of the mirror, we know reflection, what is it? After hitting the surface, it bounces back, right? So when it reaches this point, what happens? It just bounces back like this. Also at that point, what happens? It just bounces back like this. Okay. Similarly, from this end, let this be the incident ray. Let these two be the incident ray. Okay. So after reaching the surface, it is bouncing back. This also it is bouncing back. Okay. So we need to find where the image is formed. See, when we are looking through a plane mirror in front of a dressing table, when we are standing in front of a dressing table, our image, we can see our image inside the mirror, right? Inside the mirror, we can see our image. So that is a plane mirror. So how to draw a image in case of a plane mirror is, we need to extend these rays back. Okay, so for example, this touches this point and similarly I am extending this also. For example, this touches the same point and this is where I will receive my image. That will be A dash, B dash. Okay, this will be A dash, B dash. And if you are using a proper scale, you will find to know that both the sizes of this object as well as the image will be the same. Okay, size of the object as well as the image will be the same. So this is our object and this is our image. Okay, both the sizes will be same. Okay, and one more thing is, if you're using a proper scale, you will get it. This distance and this distance will be the same. Actually, here it is not the same, but when you're using a scale, you will get the same distance. Okay, so if this distance is 5 centimeter, then this distance will also be equal to what? 5 centimeter. Okay, so how can we write the characteristics of an image formed, or how can you write the properties of an image formed by a plane mirror? Properties of the image. The first property is the image will be virtual. Virtual means it is formed inside the mirror. Okay, it is formed inside the mirror. That is what is called as virtual. The second one is it is upright, or we'll call it as erect. That means it is straight image. We have a straight image. Third one, same size. The size of the image as well as size of the object are same. Okay, virtual means it is formed behind the mirror. We'll say that it is formed behind the mirror or inside the mirror. Okay, and the fourth one is image distance will be equal to object distance. Image distance will be equal to what? Object distance. So these are the important properties of an image formed by a plane mirror. Okay, so whenever we are considering a plane mirror, this is how we will get an image. The size of the object as well as the size of the image will be always same, and the distance from the object to the mirror as well as distance from mirror to the image will also be the same. The image will be a virtual image and it will be upright. Okay. Okay, now let's discuss about our next topic, what is called as spherical mirror. Okay, what is called as a spherical mirror. So you consider a spherical glass, a spherical ball, okay, a glass ball which is spherical in shape. If we are cutting a single piece from the spherical ball, then we'll get a spherical mirror, a single part. If we are cutting a single part, it will have two surfaces like this, right? If we cut a small piece from a glass will have two surfaces like this. So this forms the spherical mirrors. Okay. So when we speak about spherical mirrors, we have two types of spherical mirror. One is called as concave mirror. Okay, one is called as concave mirror and the next one is called as convex mirror. Spherical mirrors are of two types. One is concave mirror and the next one is called as convex mirror. So concave mirror means this is how a concave mirror looks like. This is how a concave mirror looks like. That means the coating will be outside, reflection happens inside. Okay, what happens? This is how a concave mirror looks like. Okay, the coating will be outside. The coating will be given on the outside of the mirror. Reflection happens inside the mirror. This is how reflection happens. So this is what is called as a concave mirror. So like this, like if you put your hand like this, the outside part, this part is the concave mirror, the poly surface, and all the light rays falls inside it. Okay, that is what is called as a concave mirror. The convex mirror is just the opposite. Convex mirror is just the opposite. Okay, so it will be polished inside and reflection happens outside. It will be polished inside and the reflection happens on the outside end of the mirror. So this is how a concave and a convex mirror looks like. Both are spherical mirrors. So concave mirror means reflection is happening on the outer inner side and it is polished on the outer side. Convex mirror, it is polished on the inner side and reflection happens on the outer side of the mirror. Okay, fine. Now let's see what are the components of a mirror. What are the components of a mirror? Okay, so first is center of curvature. The first component is center of curvature. So if you draw a circle or a sphere, and this will be the center of the sphere, right? This will be the center of the sphere. So if I am cutting a small piece from this, then this gives me a spherical mirror. This is by spherical mirror. So center of curvature means the center of the sphere from which the spherical mirror is taken out. That is what is called as a center of curvature, and we will represent it as capital C. Okay, center of curvature means what? The center of the sphere from which the spherical mirror is taken out. So if we are considering a concave mirror, okay, so let this be the circle or let this be the sphere, and I cut a concave mirror from it, and this is the center. Okay, in case of a concave mirror, the center of curvature will be in front of the mirror. This is the front portion, or this is a reflecting surface, right? So the center of curvature will be in front of the mirror. But similarly, if I am taking a convex mirror, so this is the poly surface, this is the center of curvature, right? So this will be behind the mirror because this is my polished surface. So this is my reflecting surface. So it is behind the mirror. Okay. So in case of a concave mirror, the center of curvature will be where? In front of the mirror. Okay. And in case of a convex mirror, the center of curvature will be where? Behind the mirror. Okay. The next one is radius of curvature. Okay. So let this be my sphere from which I am going to take out a spherical mirror. I am going to cut a spherical mirror, and this is a center of curvature. So if I draw a line from this point to any surface, any point to the surface of the mirror, then this forms the radius of curvature. Okay. So this is the center of curvature, and if I am pointing any point, so for example, if this is the line which touches the surface of the sphere, then this is called as a radius of curvature. Or so this is the center of, and if I am drawing like this, and this is the radius of curvature. Okay, so distance of any point on the mirror from the center of curvature. Distance of any point on the mirror to the center of curvature is called as radius of curvature. Okay. The third one is aperture. Third one is what? Aperture. So this is your concave mirror, and this is the reflecting surface, right? This is the reflecting surface. So aperture means the entire reflecting surface. The entire reflecting surface is called as aperture. Entire reflecting surface is called as aperture. Entire reflecting surface is called as what? Aperture. The fourth point is pole. Okay, so if this is the aperture or the reflecting surface, then the midpoint, what is that? The midpoint of aperture is called as pole. The midpoint of aperture is called as pole. Okay, now the last one, principal axis. Principal axis. So this is my reflecting surface, this is my pole, and this is my center of curvature. So any line which joins the center of curvature and the pole is called as a principal axis. Okay, a straight line which joins center of curvature and principal axis is called principal axis. Is it clear? A straight line which joins a center of curvature and principal axis is called as the, sorry, not principal axis, center of curvature and the pole, not the principal axis, center of curvature and the pole is called as the principal axis. Is this clear? So this is what is called as the major components of a mirror. So first one is center of curvature, the second one is radius of curvature, third one is aperture, fourth one is pole, and the last one is the principal axis. Okay, last one is the principal axis. Okay, fine. Okay, so this is all for today's lecture. So we'll deal with the next topics like how we have to draw the standard incident rays and the ray diagrams of a concave mirror and what is a focus. We will learn all this in the next class. Okay, so till then, take care. Bye bye.